because we've only got point masses acting on this, and these are not held as pivot as fixed points, we know that the bending moment will linearly increase between A and B. So a way that we can think about that is that the net force which is acting on this, if you were to take moments around just here, it's going to be slightly higher. There's going to be a net clockwise force. If you take it a little bit further, you can take moments around there and it's going to be a bit higher because you're getting closer to the force. If you get in a little bit further over here, it's going to be even higher. And that relationship, if you were to take it at if you were to take moments like we did this, at every single point, it would increase. Your answer would just go dot 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 all the way here, giving us this. A little exercise that you can do is you can say, well, maybe I could take the moments around here, and this should give me 2.25. So if you want to prove to yourself that this linear relationship holds, you can try and take moments around this point here, which is 0.6 meters from the start. And you should, by calculating this times 0.6, this times 0.6, this times 1 meter, and this times 1 meter, should give you 2.25 as your net moment. But it's just good to remember that this is just a linear relationship as you get from A to B. And then the same holds from B to C. So this will go from 4.5 all the way down to 0. And again, a way that you can prove to yourself that this works, that this is linear, is you can say, well, what is the bending moment here? What's the bending moment at 1.4 meters? So 1.4 meters, which is the distance from there to there. You can say, well, I'll take bending moments about here and do the exact same as what we did for like A, B, and C, but take it about this point here. Let's call this D and call this E. You can say, well, what are the moments about E? And you can say, well, we've got this 16.25, which is acting up, so that's going to be negative, and it's 0.2 meters away. We've got this 5 kilonewtons, which is going downwards, which is clockwise, which is positive, and that's 0.2 meters away. We've got this 15, which is acting, and we've got this 3.75. And you should, again, because it's symmetrical, you should get 2.25 kilonewton meters. So this is how we've arrived at the graph, and we've made sure that we've stated what the height is at A. We can also, just for clarity, say that it's also 0 here, and it's 4.5 kilonewton meters there. So this is your bending moment graph. I suggest that you go and try it for yourself and see if that works. And yeah, do these little checks to make sure that you understand A, what's gone on, and B, to prove to yourself that this should be a linear relationship here. Okay, I hope that helps. Get in touch if not, and yeah, I'm sure you'll be able to do it. Okay.